This is Mrs. Palmer-Quay with the first video for Module 3. In this video I want to talk to you about matter, and I'm going to cover some topics that are either covered later in your textbook or are not mentioned at all. But because I feel it will be useful to you to know these things going into this module, I want to talk about them today. First, let's review. What is matter? In the very first module, you learned that matter is anything that has mass and occupies space, has mass and volume. I want to add to that two other characteristics of matter. Matter exists in a particular state at a given temperature, and I think you're familiar with that, where we have things that are either solids or liquids or gases, or perhaps you even know about plasmas. And matter can also be understood in terms of its composition, what it's made of, and its properties, how it behaves. Under composition, we divide matter into substances and mixtures. And under properties, we talk about the physical properties and the chemical properties. Today, I just want to talk about the physical properties. Chemical properties will be coming. I think you're really familiar with the states of matter from your science classes earlier in your life. We just want to add this idea that the change from one state to another is governed by the amount of thermal energy inside the substance. If you remember from our energy discussion, thermal energy is directly related to the kinetic energy of the molecules and atoms that are inside that substance. And so as kinetic energy, or the energy of the movement of those atoms, increases, the thermal energy increase, and we see a change of state. Something can change from by the addition of energy, change from a solid to a liquid to a gas and eventually to a plasma. Here's another illustration of the states of matter. In a solid, the particles are very closely packed together in a regular pattern. The molecules do have some movement, but it's very, very small, and the amount of attraction between the molecules is very high. As energy is added and it moves into a liquid, the molecules decrease in the amount of attraction because they have a little bit more energy to move apart, and so that allows a liquid to have sort of that freely flowing characteristic. It has a particular volume, but it doesn't occupy a particular shape. If you think about how, water, when you pour it out, it just kind of spreads all over the place. As we add more energy and a substance changes from a liquid to a gas, the amount of kinetic energy in these individual particles is so great that attraction is really not existing anymore between them. If you release a squirt of perfume in one corner of your room, you will eventually smell it in all corners of the room as those particles spread out in all directions. And finally, at very, very high temperatures, the atoms themselves do not even stay together. The positive protons will separate from the negative electrons, and though we'll have sort of a cloud of all these particles, they are not arranged as individual atoms anymore. When it comes to the composition of matter, we divide it into whether a piece of matter is a mixture or a substance. We'll be doing a little bit more with mixtures in the next module, but I'll just give you the definition that a mixture consists of two or more substances that can be separated by physical means. It's something that you don't have to undergo a chemical change to make the pieces of a mixture separate out. A substance will be composed of either elements or compounds made up of those elements. So an element is something that cannot be decomposed, whereas a compound can be decomposed into two or more elements. The decomposition of a compound, though, requires chemical means. It cannot be done by a physical change. So mixtures can be divided by physical change, but compounds can be divided only by chemical change. Most of the things that are around us in our environment are mixtures. So the things that we eat, or the substances that we clean with or wear on ourselves are mixtures. They may seem to be holding together as if they are a pure substance, but in reality it is possible to separate out the components. And some things, like peanut butter, especially the natural forms, will separate over time, putting a layer of oil on the surface. So mixtures can be something that is a more solid form. I don't have any, baking soda would be an example of several solids that are put together. But all of our things that are in solution, these various chemicals over here on the right, are in solution, there's something dissolved in water. Those are considered mixtures because we can get that particular substance out of the water by evaporation. Substances, though, are held together and cannot be separated. Either they are elements, like sulfur, this is the pure form of one element, or copper, or they are compounds, two or more elements put together. So we have mercury oxide, so mercury and oxide are bound together. Sucrose is actually a combination of two larger molecules, glucose and fructose, and within those larger molecules you have carbon and hydrogen and oxygen. Copper sulfate contains copper and sulfur and oxygen, along with this pentahydrate tells you there's some water molecules in there. Sodium chloride, we'll be using this a lot as an example because it's such an easy thing to write. It's just Na, sodium, Cl, and we'll go on to all these atomic symbols very soon. So these are some examples of substances, things that are either a pure element or a compound made up of elements that the parts cannot be separated without chemical decomposition. And then finally, the physical properties. Physical properties are things that can be observed about matter without changing the substance. So we can look at something and see its color. We can bend it and see if it's malleable, if it bends easily like a piece of wire, or brittle, if it snaps. Is it hard or soft? Is it soluble? Does it dissolve in water? Does it dissolve in oil? Is the substance something that will conduct electricity? Does it react to a magnet? What temperature does it melt, go from a solid to a liquid, or boil, go from a liquid to a gas? And of course, thinking about your last lab, what is the density? These are all things that we can observe, we can measure without doing anything that would change the substance. And they're all intensive properties. It doesn't matter if we're measuring a large container of vegetable oil or a small amount of vegetable oil. They would all have the same density. There are also extensive properties. These are things that will change with sample size. So the given mass of a sample size depends greatly on how much you have, as does the volume. But the density, the mass divided by the volume, will not. So just to summarize, when we think about matter, we think about what state is it in, a gas, a liquid, or a solid in most cases, since we're not going to be dealing with those very high temperature plasmas. And then is it composition? Is it a mixture or a substance? And we'll get into the difference between heterogeneous and homogeneous mixtures in the next module. And then substances can either be elements or compounds, and compounds can be broken down into elements by chemical means. So this covers what I want to introduce to you about matter. The next video will begin our look at the elements by considering the periodic table.